Hello, everybody. 10.1 coming at you live on Thursday, February 8th, 2024. Let's see if I can fit in this desk. Oh, yeah. Okay. Um, hey, we're going to be working with more rational functions today, or rational expressions, I should say. Remember, a rational expression or a rational function is a quotient of two polynomials. We're going to take a polynomial over polynomial, and we're going to simplify the expressions. Okay? This is basically what happens when you multiply or divide one rational expression by the other. All right, here is the box that tells you what you're going to do. I'm going to go ahead and just explain what we're going to do by working in examples. Let's jump into example A. It says multiply or divide, simplify your answer if necessary. Okay, so is this multiplication or division, first of all? Multiplication, how can you tell? Big dot, right? Big dot, multiply. So I have a polynomial over polynomial, so I have a rational expression, x squared over x squared, and times a linear polynomial over a quadratic polynomial. Okay, this thing is going to multiply together and it's going to simplify. Now, here's what you don't want to do. You don't want to just start foiling it out. You don't want to just start foiling it out. Don't do that, okay? So you're going to actually do the opposite of foiling it out. You're actually going to do what as your first step? Step one. You're going to do the opposite of foiling it out. You're going to factor everything. Factor everything. There's really four polynomials here. You have x squared minus 9, x squared minus 5x minus 24. You have x minus 8, which is already factored, right? It's linear. And then you got another quadratic down there. We're going to factor everything. All right, so here's what I'm going to do. Since it's multiplication, the other thing that I'm going to do is I'm going to make it into a single fraction. I'm going to put one big horizontal bar. Because really, you can just multiply straight across. That's how you multiply fractions. You multiply straight across. So let's go ahead and factor the x squared minus 9. Y'all recognize how to do that? Is there anything common in x squared minus 9? We look for that first. X plus or minus 3. X plus 3, x minus 3. Good. That is a difference of squares, and it factors into the product of two whatchagates? Conjugates. Excelente. Now, x minus 8 is already a linear factor, so we just write it like that. We put them in parentheses. That implies multiplication. All right. So far, so good in the top. All right. Now in the bottom, I'm going to have to double bubble this fella. Is there anything common in these three terms? Oh, you already have them. 8 and 3. So the answer is no. There's nothing common. So we double bubble it. Factors of 24 that add or subtract to 5. Which one's positive? Which one's negative? 5. Donde está 5?
3 is positive.
3 is positive. 8 is negative. Right. That gives you a negative 8 on the inside and a positive 3 on the outside. Their product is negative 24 when you do the last on the FOIL. But the inner and outer give you negative 8 plus 3, which is negative 5. Very good. And then we got the last one here, the 2x squared minus 18x. Is that one going to double bubble? That's only two terms. Greatest common factor. What's common in both of those? 2x. I'm going to put a 2x in parentheses. Since it's in the middle of another expression, I put it in parentheses. And when I factor out a 2x from each term, what do I get for the first term? X minus 9. There you go. Now it's completely factored, and it's all in one big expression. So remember what happens when you have things that are multiplied from high to low. Any common factor divides out. So that's our next step. We're going to number two, we're going to divide out, not cancel. We're going to divide out common factors. It has to be the exact same. Do we have any common factors on the top and bottom? What? Give me one. X plus 3. I usually make the sound when they divide out, but you can cough if you want. Oh, the x minus 8s? They divide out. Anything else? No. So what are we left with? We're left with x minus 3. And since it's the only thing left in the top, do we really need parentheses around it? No, we don't. It's by itself. And in the bottom, I can get rid of the sum of the parentheses. I don't have to put the 2x in parentheses, and I have x minus 9. All right. So this would be one version of the answer, or it depends on what we want to do with it. If I want to find the domain of this function, then I'm going to leave it factored, right? I'm going to leave it factored because I don't want to divide by 0, and I know x can't be 0 or 9. But if I want to like find the end behavior or the y-intercept, I might just redistribute it here. So if I distribute the 2x back in, I get 2x squared minus 18x. So either one of these are considered simplified answers. Meaning if it's a multiple choice question, the answer choice might be redistributed or it might still be factored out. I'm okay with leaving it in the factored version on top once you're done. Okay, that's it. That wasn't that hard, right? No, that was it. Factor out everything, divide out common factors, and then just repackage your final answer. That's multiplying. That's when it starts as multiplying.
That's it.
There's one more step if it's like B that we have to include. This is a constant over a quadratic divided by. Oh, it's divided by. So if it's divided by, there's actually a step 0. Okay? Step 0, which comes before the factoring everything. Okay? Change division to multiplication. How do we change division to multiplication? There's a little quote. Stay, change, flip. Y'all might have learned to just keep, change, flip. Y'all like keep, change, flip better or stay, change, flip?
I really stay.
I learned it as stay, change, flip. So I'll do keep, change, flip. Keep, change, flip. I think I like stay better because it has the long A sound like the second word. Stay, change. It almost sounds like they're almost rhyme. Stay, change, flip. Stay. And also like you're talking to your dog too, right? Like stay, stay. All right, change, change. All right, now flip, flip. Good boy, good boy, good boy. Right? Can you imagine the dog when you command him to change? What's he's like? You want me to like pretend I'm a cat now? What do you? How do you want me to change? Right? Yeah, meow, and then flip. That would be cool. Yeah, good boy. So keep, change, flip, stay, change, flip. It doesn't matter. So let's do that. We get 20 over x squared minus 7x. We keep the first expression or it stays the same. That's why it works both ways. You either keep it or it stays the same. And then we change division to multiplication. And what do we do with the second expression? That's important.
Flip all the signs.
No, you don't flip all the signs. The numerator and denominator flip. Okay? You don't change all the signs. They just change locations. They change locations, not signs. That's important. They stay the same. They just change locations. So stay, change, flip. Stay, change, flip. Keep, change, flip. All right. Now it looks a lot like what we did on part A, doesn't it? Now it's multiplication. So now we can go back to step 1, which is to do what with everything? Factor it. And now that it's multiplication, I make one big vinculum and I put it all. I get rid of the dot and just extend it out. 20 is already factored, right? It's a constant. A vinculum.
What's that? Wait, what is the bar?
That's the bar. Yeah, the bar is called a vinculum. Now you know. Yeah, you could also call it just the horizontal division bar, but it's also called a vinculum. All right, the next one, it looks like it double bubbles, doesn't it?
Yes.
X and X. Here we go. Factors of 56 that add up to 15. 8 and 7. That's beautiful. All right. Now I need to work on their SIGN sign. Is one positive, one negative, or one of each? Both positive? They're both negative. If you need help factoring, because there's a lot of factoring going on, you need to come see me in tutorials before school, and we will just work on factoring, okay? Because that can't be the obstacle to doing these problems. You have to know how to factor. All right, in the bottom I got x squared minus 7x. First rule of factoring is to greatest common factor. What's common in both? X. So I factor out the x, and I get x minus 7. And you can put the x in parentheses if you want. Everything gets parentheses. It makes it nice. Like the 20 got parentheses. And then the last one down here, first rule of factoring is to look for a common factor. What's common? 5 and x, right? 5x. And that leaves me an x minus 8. Yeah. So that's step 1. Factor it all out. Step 0 is to stay, change, flip. And now step 2 is to what? Divide out your common factors. So See ya, wouldn't want to be a x minus 7. Adios, hasta luego, x minus 8. And now you take inventory. I'm left with a 20 in the top, and in the bottom I'm left with an x times a 5x. Okay? And the x can be written without the parentheses because it's in front. This one, since those are like factors, that's the same as 20 over 5x squared. And is that as good as it gets? No. We can simplify the numbers here. 20 divided by 5, they have a common factor of what? 5. They have a common factor of 5. Yeah. So they divide out nicely to give you 4 over x squared. Yeah. If you wanted to, you could show this intermediate step. They're not always going to be one perfectly divided by the other. They may just have a common factor of 2. But 20 you can think of as 5 times 4 all over 5 times x squared, like that. And then what happens with the 5s? They divide out and you get 4 over x squared. Either way, you can show that extra step. So you mean to tell me that this expression right here is exactly the same as this expression? Yeah, yeah. Now there's one last thing that I forgot to mention up here. Okay, you want to know where the values are excluded, and I forgot to do that on the first one. So let's come over here. Let's just come off to the side and get an exclusion table. X cannot equal. Any value that makes a denominator 0 is off limits. Any value at any time that makes a denominator 0 is off limits. And we have to do it before we get rid of anything. So what value of x makes x minus 8 0? 8. So 8's off limit. What value makes x plus 3 0? Negative 3. Good. What value makes 2x 0? Not 1. Not 2. 0. If you have a factor of just x or 5x or something times x, 0 is what makes it 0. All right. What root makes x minus 9 0? 9. Okay. And that's it. Those are the excluded values.
Well, what's undefined?
That's the same thing. Yeah. Yeah. Oh, is there? Okay, let's just move it down there. Thank you. I didn't see that. Sometimes I get tunnel vision. Notice they don't have that on number 2 or letter B. All right. Now, if you do state change flip, you're going to have to be careful here. I didn't state change flip it when it's factored. Let's go ahead and go through and say on this line right here what x cannot equal. If the factor is x, what's the root of x? Not 1, not 2. It's 0, right? It's 0. Okay. If x minus 7 is in the denominator, what's the taboo value of x? 7. And if x is another root, what's its taboo value? 0. We already have that listed, don't we? We don't have to list it again. Yeah. What about x minus 8? 8. Now, there's one last thing to consider here. You got to be careful. I will use Dora's expression here. Cuidado, cuidado. Okay? It means be careful. Look out. Because we state change flip, didn't we? This right here used to be in the denominator, didn't it? And when we flipped it, it became in the numerator. So I have to look at these two factors right here as well. They used to be in the denominator. What values make those 0? 8 and 7. Do we already have them omitted? Yes, but could that have been another factor that we didn't omit? Yeah, so you have to make your original denominators find the taboo values, and your new denominators, you have to find the taboo values. Okay, so here are the taboo values or the excluded values.
What about the 20?
No, the 20 is just a 20. Yeah, 20 is just a number. If it doesn't have a variable, you don't have to worry about it.
Oh, and X?
Oh, we did x twice, so it can't be 0 and it can't be 0. We don't have to exclude 0 twice. I kind of hurt 0's feelings. You can't come, and you can't come, and you can't come, and you still can't come, but you can't come either. Oh, you already told me. God, why'd you do it again? Right? Or you're like saying, I hate peas, I hate carrots, I hate broccoli, I hate peas. Right? You already said that. You already said you hate peas. You must really hate them. That was roll off my plate. Those little round green things. All right. Guess what I'm going to have you do on letter C? Do it by yourself.
Quietly on the board.
Right. If they were still aboard, I'd go up and I'd be writing on the board right now. Very good. Very good. But it's not 1990. Actually, when I first started teaching in the early 2000s, I was still writing on the board. Yeah. Okay. I'm going to do it quietly on my iPad. You do it on your iPad, and we'll compare answers. Okay. Yeah. So now this factors again. So just rewrite everything and factor that. Right? You pull out a common factor, but then you look to see if it factors some more, and it does. So everything else just gets rewritten. Remember, factoring might take more than one step. Something may have a common factor, and then it may factor after you pull out the common factor. That's what happens in the first of all, I'm going to draw one line across, one vinculum instead of two with a dot in between there. And then there's really nothing to do with the 3x squared, but the top right, I factor out a 2 first, and that leaves me x squared minus 3x minus 10, which if you notice that right away, you can divide it out with the x squared minus 3x minus 10 right away that's below it. But that won't allow you to find the excluded value. So in general, we still want to factor everything out. The bottom, I have a double bubble. and then I have another double bubble, and then I go down to the next line. Notice everything that's highlighted just got rewritten. I did combine the 3 and the 2. You can call 3 times 2 6 if you want. So it becomes the 6x squared over the bottom, and then I focus on the unhighlighted trinomial, and it factors into x minus 5x plus 2. Once everything is on one vinculum and everything is factored out, then you can get divide out happy. Whatever.
What is 0?
Well, that x is in the top. If it's in the top, it's okay. We're only trying to avoid zeros in the bottom. Yeah, we only do the ones on top if it was in that second one we were dividing. Okay? Yeah. Only on that second one when we're dividing. We'll do that on the next one. But if we never have to flip anything, then we're just looking at the denominators. Okay? Bless you. Okay? I'll just make a point here. We're trying to avoid zeros in the denominator. Any denominator.
So if it says like 3x squared in the denominator, then you put a 0?
Correct. Yeah. That's a bad any. Yeah, in any denominator. All right, so the excluded values are just the roots of the factor denominator, which are 4, -2, 5, and -2. But we don't have to list -2 twice, do we? Nope. All right. Y'all do this one now on your own. This is division, so we got that one extra step, step 0. Okay? I'm going to do it quietly by myself, and we'll compare answers. What's that?
Yeah.
Oh, -11? Oh, -11 is okay. We're trying to avoid zeros in the bottom. Is this x plus 11 ever in the bottom? Was it ever in the bottom? Never. We only try to avoid zeros in the bottom. So -11 is okay. But the reason I highlighted x squared plus 2x minus 3 is to remind myself that, hey, he started in the bottom, didn't he? So he potentially had division by 0. Now he's in the top. And then I created a new bottom with the 2x plus 6. So once we have it completely factored out, you notice that I'll use a different color here. When x is in the bottom, that means x can't be 0, correct? When x plus 3 in the bottom, x minus 3 can't be 0. And then there was an x plus 3 in the bottom to begin with, but it's already in the bottom, so I don't need to count it twice. But there's another guy here. The x minus 1 was in the bottom to begin with, so x can't be 1. But the x plus 11 was never in the bottom, so -11 is okay. He's the only variable factor that has a root that's allowed. So kind of an oddball right here. Notice it didn't ask you for the excluded values. So what I'm thinking is your homework is not going to ask you for the excluded values on the division because it's too advanced for y'all to think about what used to be in the denominator was now in the numerator. If this were my class and it was on a class, I'd have you find the excluded values. But I think it's going to ask you just for the excluded values on the multiplication, which means you never have to worry about something going to the top. You just look at the values that make the denominator 0, and it'll be consistent all the way through. All right, that's it. That's this whole lesson. It's just divide or multiply, multiply or divide, factor, divide out, and then find excluded values. Do y'all have any questions on that? Tomorrow. Yeah, tomorrow we're starting 10.2. So the homework is due Friday at 9 a.m. And we'll take 2 days on the next section, but this is a pretty easy 1 day section. So, okay, you have the rest of the period to work on your homework.